Hi, we are going to go through the parachute drop lab and get all the stuff that you need in order to complete this lab the rest of the way. If there were no parachute, so there was no air resistance, we would expect the acceleration of the parachute to be 9.8 meters per second squared because the person would fall just in gravity. Since there will be significant air resistance because we're using a parachute, we would expect that they would fall slower than normal. So instead of falling at 9.8, we would expect that the number would end up being a smaller number. We're going to go ahead and label the two forces that are acting on our parachutist. So if I click Edit, it takes us into that drawing window. There are two forces. We know that gravity is going to make our person fall. Let's make that a little thicker. And let's make a purple one up. And then we can label that as being the force due to gravity. So we call that Fg, G for gravity. Our force that's going up is going to be the air resistance. And if we didn't have any air resistance, all we'd have is that force of gravity going down. And it would fall at 9.8. But because we have an air resistance force that's going up, we expect to get less than 9.8. So when we label this, I'm going to call that F air for air resistance. We want to know what the direction of the net force is. The way that we move is the way that our direct force is pointed. So since our parachutist isn't going to keep floating up, they're going to instead fall down, then we know that the net force has to be down. There are two equations for net force. We can find one of them on our equation sheet. So here we go. Net force is equal to ma. And our other equation is based on Fg and F air, because we know that those two forces pointing in opposite directions will have a net force where we take the bigger force minus the smaller one. All right, so we're going to watch the videos to get the data. So let's do that. Let's watch the second one first. Of the parachute and Einstein. Goes 75.5. Yeah, let's go 75.5 grams. Okay, so once that's settled, our total mass in grams is going to be 75.5. There are 1,000 grams in 1 kilogram, and we need kilograms. We don't want grams. So what we do is we divide the 75.5 by 1,000. That'll give us 0.075 kilograms, and that's what we're going to want to use. So now let's watch the second video to get the distance, the time, and we'll figure out the average time. So Mr. Reeves and Mr. Moriarty got exactly the same times as each other, which is pretty amazing. That will make our average a lot easier to do. So we have a distance of 5.45 meters. Time 1 was 3.29 seconds, and our time 2 was also 3.29 seconds. And so our average time is 3.29 seconds. Cool. So now we're going to do our calculations, or I'll at least get it set up for you for how to do the calculations. So we want to know the weight of our parachutist with the parachute. We know the person's mass, or we know Einstein's mass with the parachute, is equal to 0.0755, and I left off a 5 up here, so I'm going to put that back. We also know, whoops, and that was kilograms. We also know the acceleration due to gravity is equal to 9.8 meters per second squared on Earth. And when we're looking for weight, we're looking for Fg, the force due to gravity. So if we go to our equation sheet, we can find that equation right here. Fg is equal to mag. So you might have been wondering why we're using the acceleration due to gravity, because we said that it wasn't going to fall at 9.8, that it was going to fall slower than 9.8. But when we're finding the weight, weight is due to gravity, so we want to use the acceleration due to gravity. So that's Fg is equal to mag. And you're going to go ahead and plug in those values, and you're going to get the weight. I'm going to call that Fg equals, and you'll write in what you get. To get the acceleration, we know that Einstein started from rest, because that's how I dropped him. We also know that the distance that he fell is equal to 5.45 meters. And we're going to use the average time, which is the same as all of our times, which is 3.29 seconds. We are looking for his actual acceleration that he had. And so we need an equation that will use all of these things. So if we go to our equation sheet again and look for acceleration, you can see that we have v final minus v initial over t. We don't know v final, so that doesn't work. But the second equation here is 2d over t squared, and that's exactly the givens that we have. We have distance and we have time, so that looks like a good one. So I'm going to go ahead and copy that. And paste it in here. So then you're going to get a value for acceleration. And I'm going to call that value x. So whatever you get, that's what you're going to use. Now we're going to find the net force of our parachute. We know what the acceleration of Einstein is because we just figured it out. So that's that x value. So you'll replace that once you figure it out. We also know the mass of Einstein is equal to 0.0755 kilograms. We are looking for net force. Since we have two different equations to find net force, you can see them right here. We've got net force is equal to mass times acceleration. We've got net force is equal to Fg, whoops, that should be a minus sign, minus F air. We don't know what F air is yet, so we can't use this equation. We need to use this one. So F net is equal to ma. We have our mass, we have our acceleration, and so we can calculate that F net. And I'm going to call that no, we'll just leave that. Now we want to know the force of air resistance. We know what the net force is. That was our answer to number 3. We also know what our force due to gravity is. That was our answer to number 1. We're looking for our force of air resistance. If we look at our second equation that we have here, it's solved for F net, but we could rearrange that equation to solve for the force of air resistance. If we subtract Fg from both sides and then multiply by a -1, we're going to get F air by itself using some algebra. So F air is going to be equal to Fg minus F net. So you can take those two values that you have. I'm going to call F air, and it should be a pretty small number. Let's call that Z. So now the problem that you're going to be using on today's review. So if the object, so our Einstein, were safely replaced with a baby chihuahua, and let's say that the baby chihuahua has a total mass of 0.45 kilograms, we want to know what the actual acceleration of the chihuahua would be. So it won't be 9.8, it'll be smaller because we'll be falling in gravity or with a parachute, so air resistance will be a factor. We're going to use the same air resistance as we did in question 4 above, and then we're going to figure out what that net force is and then what the acceleration is. So the first step, we're going to take the mass equal to our baby chihuahua's mass. And we also know the acceleration due to gravity. We are looking for the weight of our baby chihuahua. So use your equation from above to figure out what that would be. And that should be in newtons. Then we need to know what the net force is. We're going to know what Fg is. We also know what F air is. And we know this because we calculated it up above. That's our Z. We are looking for net force. Now we can't use the acceleration because we don't know what the acceleration is. So in this case, we're going to use that other equation that we'd written up here to figure out what our net force is. And the next step is to figure out our acceleration. We're going to know what net force is. And we also know what the mass is. And that was 0.45 kilograms for our baby chihuahua. We're looking for the acceleration. So in the equations that we use, we know what the net force is, we know what the mass is, we can figure out the acceleration. So you're going to go ahead, figure out the weight is, get a number for that, plug it into here, figure out your net force. So we know what the air resistance force is because we calculated it up here. We know what the weight is because we just calculated it. We're going to subtract those two in order to figure out the net force. So this is like all of those examples that we did on last week's practice where we had two forces that were pointing in opposite directions, and we subtracted the two of those in order to get the net force. So that's what we did. Then once you have the net force, you just figured that out. You know the mass of our baby chihuahua. So now you can find the acceleration by doing the net force over the mass. This is the most important part of the parachute lab, is this calculation right here. And when you're doing the review, this is the one that you're going to be copying into your review document. But you need to finish this one and figure out the air resistance force before you can do this one. So I'll stop talking so that you can get started on that.